Oh boy. Alright, we gotta do it. We gotta do the intro over again.
Welcome to our second day of Robot 3 Days. The programmers are working on a way to move a tape measure across the field. We are working on launching airplanes and a way to hang ourselves from the trusses. Have fun.
Alrighty, so I got our first winch design. Alrighty, so I got my first winch design done here. As you can see, we just have some PETG filament that is not printed on here, and we have this paracord which is connected to a pulley at the bottom, which has just a 30 RPM motor on it. So ideally, we'll be able to just spin this motor and it will pull this down, and that'll be good. We're currently waiting for the field to be finished being built and for the programmers to get this all programmed up. But once we get that done, hopefully we can test it.
Okay, so I have been working on our counter-rotating plane launcher. Currently, a problem with it is because of where the gears are. It likes to just launch on the airplanes and rip them apart, like this one.
You can see how it has all kinds of like ridges on it.
Yeah, and it doesn't fit very well. So, gotta try to move the gears underneath the U-channel, low U-channel, and hopefully that'll help.
You want to show them how it works real quick?
Yeah.
I'll help you out. Yeah, we're currently just running it off of the battery. So, oh, I wasn't gonna hold that. But.
There you go.
Yeah, there you go. Which way do I plug it in? I assume negative to negative?
Yeah.
Oh, that was actually like the best one.
Yeah, that's like the best launch. Let's go.
Yeah.
Okay.
Yeah, most of the time it just like gets in the gears and kind of gets chewed up.
Yeah, and gets ripped to pieces.
Alrighty. So we were gonna try to use the tape measure design that we had from a while ago, but as you can see, we hooked it up to a servo tester, and it basically just completely unwound the tape measure that we had in there. So yeah, this is pretty much unusable now. So we're switching to just using a regular tape measure with a zip tie on it so that it doesn't lock. And then we're gonna have like a wheel on top to roll it out, ideally. So that's the idea. Hopefully we can get that done before Robot in 2 days is over. Alright, so after the crushing failure of the other tape measure design, we have zip tied a tape measure to some wheels and powered the wheels with a motor, and it actually works quite well. So I'll have Zach hold it here. You can hold it by the motor too, that's a good spot to hold it. And pretty quick, and it also is it's a lot more structurally sound than the other one, because the other tape measure was really small, so it just kind of fall apart. So yeah, and also quite quick.
Attack him.
Okay.
So I've been working on our counter-rotating paper airplane launcher. We are using 2 gecko wheels that are counter-rotating using 2 gears and a chain. It's hooked up to a 1260 RPM motor we have hooked into a control hub. So can you grab a controller so we can show it?
Are you ready?
Yep.
I don't know which direction it's gonna go.
Oh, okay. Always the wrong way first. Okay.
So yeah.
Looks like it needs more power. Woo!
It made it.
Woo!
Let's go.
That's pretty good. Now I gotta figure out how to feed it in there. Alright.
That's not how you do it.
Yeah.
You ready?
Yep.
Oh, you went through.
Yeah.
Aim it up more, Zach.
Yeah, I need to aim it up. Yep.
No.
Yep. Ah. Yep. Nope. Yep. Oh, it goes down too quick.
So we got the tape measure contraption connected to the robot, and we can actually control it now. And as you can see, we got the reverse snowplow on there now, which is pretty much just kind of a arc shape that's backwards, so that way we can use it to grab onto the pixels and then kind of pull back, ideally. Obviously, we could probably use a little bit more refinement, but hopefully this means that we can use this to go out and grab the pixels quickly and bring them back in. Oh, look at that. Okay, if you go too far, it does break though. You can, however, like... Nope. Yeah, if you go too far out, you just kind of don't have any more control over it. Yeah. But other than that, it looks pretty good. So maybe we should work on making the plow even lighter. I don't know how we're going to do that though. But yeah,
So I worked on the rotary pickup some more. It didn't hurt anybody's fingers today, but I kind of made a cardboard ramp for it, and sometimes it picks it up. I'd say probably like 40% of the time it picks it up, but if I can make a good ramp, then it should work pretty well. I'm also making a counter-rotating pickup with bigger boot wheels, so it'll pull it in, and then the ramp could be moved up a little bit farther for that, and then the smaller boot wheels could move it through the robot. You kind of just have to keep it on the ground.
yeah, so it kind of struggles to get it up and onto the ramp, doesn't it?
Yeah,
Huh. Hopefully the counter-rotating wheels work better with this then.
they should. That's what we all think. Oh. Just keep the front all the way down.
Yeah, it's got it on the wheels, it's just not going in.
So try it now. Yeah, it's that ramp.
The only problem really is the ramp. That's it.
Yeah, I think other than the ramp, it's probably pretty good.
Alright, turn it off.
Alright, so today I worked on this claw mechanism. It has flexible claws, so when you go to grip the pixel, they kind of form around it to... Yeah, so they form around it to kind of hold it in place. I'm having a few problems though because this material we use is kind of slick and it doesn't have enough friction between the pixel. So yeah, so the issue we've been having is this material is slick and it doesn't have enough friction between it and the pixel. So tomorrow I'm gonna print another one with this infill instead of this because this one's a bit too stiff and it doesn't quite form around the pixel. And then I'm gonna figure out a way to make this a bit grippier so it'll hang on to it. And then hopefully we'll have a working flexible claw.
Okay. So I've been step forward.
Yeah, you can walk up to the camera.
I've been working on our paper airplane launchers. So we got a one that's based on a rubber band. You pull back a 3D printed piece and let go, and it launches the paper airplane forward. Problem with it right now is that our 3D printed piece was too weak, so it broke right there. So we're printing a new, stronger one so that it hopefully doesn't break. We also need to make it so that we can lock it in place with a servo so that we don't have to use a human during a match. I also made a counter-rotating launcher which uses a 1260 RPM motor connected to 2 gecko wheels, which counter-rotate and launch the plane forward. This one works okay, but it's very bulky, it's very large and heavy. Yeah.
Alright, so today I built this flexible claw to pick up pixels. It's made out of TPU, which is like a kind of rubber that you can 3D print. And when you go to pick up a pixel, it'll kind of form around the pixel to have better grip. It's just 2 gears and then a sprocket connected to a servo, so we can control the whole thing with this little servo here. I've been running into some issues with friction between these and the pixels because this is kind of slick, so it doesn't really want to hold on to it super well. So tomorrow I might use some hot glue and hot glue some rubber bands on there to maybe hang on to it a bit better. I made 2 different types of claws. This one has 1.2 millimeter thick walls, and this one has 2.4 millimeter thick. This one's just too stiff and doesn't form around the pixel as much as we'd like to. This one forms around it pretty good. So yeah, that's what I've been working on.
So the first thing I did today was I worked on this, well, first thing we did is we tried to power this old tape measure version. So this one we fully took out the tape measure and just printed a different spool for it and then used 2 servos on it. We never actually powered it before, but the first time we did, it just completely unspooled and it's just like unusable now. So then I went and found a tape measure and made this monstrosity, but it works. So basically what it does is we just have this one tape measure zip tied on, and we also have the lock zip tied down so that it doesn't try to lock up. And then we have it going through 2 flexible wheels here that are counter rotating, and then it's attached, hooked up to this motor, and so that way whenever you run the motor, it extends out and pulls back in the tape measure. And this actually works quite well, and it's relatively fast. And we can even speed it up even more since this is only a 435 RPM motor, and we can go up to like a 1,600. So the point of this is that we can hopefully like extend this out and then like get this snowplow type thing over top of some pixels and then pull them back in. So that's what I worked on. And then I also worked on this hook design. So the idea here is that it's for hanging up the robot. So we have these this PETG, flexible PETG, like unprinted. It's just we took it straight off the spool. So the idea with this is that it can kind of flex around and stuff. And then we have some paracord also hooked up to this, and it's hooked up to a pulley down here, as you can see. So the idea is that, and it's a 30 RPM motor here. So we can just spin that and it picks up the robot. I don't think we recorded it, but this is actually strong enough to pull up the robot by itself. Problem is that this isn't tall enough. So what I'm actually going to do is I'm going to go ahead and take this hook and put it on the tape measure attachment that we had, as well as the paracord. So that way we can extend it up using the tape measure and then pull it back down with the paracord. So ideally it should be able to extend up and pull itself back down. Another problem is that we need to figure out how to stabilize it, because right now when you lift it up it just fully leans over. There's nothing to stop it from just falling, like leaning completely over. So we probably need to deal with the CG, the center of gravity, a little bit.
Okay, what I finished today, or got to a pretty good stopping point, is this rotary intake. It has these smaller boot wheels, and then it's operated by 2 chains. I also added a cardboard ramp, which it's okay, but it doesn't work every time. It probably works 40% of the time, if not less. But I'm planning on 3D printing a ramp for it. So yeah, that's what I did with that. And then I also have these counter-rotating intake, which is kind of bad right now, but I'll try and get it working tomorrow. But that's what I worked on today.
Alrighty. So we also had another person working on stuff. He's not here anymore. He had to leave. But he worked on adapting our center grabber for the pixels here. So this one can pick up 2. And I don't know if it's working right now, but theoretically, we're just using a servo tester. But when we actually plug it into the robot later and get it programmed and everything, we should be able to drop off 1 pixel and then drop off. Oh, it actually does work with the servo tester. We can drop off 1 pixel and then we can drop off the second one separately. Person who isn't here also worked on this one, which he just attached some Viper slides to the robot, and we're gonna see if these are strong enough to pick up the robot by itself. Honestly, I think they are. They seem pretty sturdy, and hopefully we can also attach like a claw to this, and then maybe do some scoring tomorrow, maybe. Alright, you're good to go.
So I can't really get up there with what I'm doing, but
We can angle it.
alright, could you hold the bobot?
Do you want to put the bubble on the field?
No, that's good.
Nah.
So
we can angle it down.
what I worked on today was programming this winch to be able to pick up this holonomic chassis here. So moving the joystick to the left tightens it to lift it up, and then to the right we'll bring it back down, and then after that, I also worked with the same robot to be able, with the same motions, extend the tape measure and then out. And then another programmer who is not here worked on being able to extend these slides out. And that's what we did today, along with paper airplane models.
Yeah.